Hello guys, welcome back to my new stream. Uh, I'm sorry for yesterday. Yesterday uh, there is an issue in my internet, so that's why it stream ends abruptly. So we are on our campus recruitment prediction project. So we are creating web app, Flask web app for our project. So we have created our index.html. Now we are working on our app.py. Here I am working on submit. So let's continue. So in HSCS we have three options: commerce, science, arts. If it is commerce, then just a second. Let me see what's our column name. It is commerce and science. Okay, we can say commerce is equal to 1, science is equal to 0. Now I'm using elif condition. Elif HSC underscore S is equal to science, then commerce become 0 and science become 1. In my else condition I will give commerce is equal to 0 and science is equal to 0. It is for arts condition. Okay, now I am taking degree score. So let's create a variable called degree s is equal to, or we can say degree p. It must be a float value, float of request dot form. It what's its IT name? It is, I guess, degree p. Okay, let me paste it here. Cool. Now what's our next field? Our next field is degree stream. So it has three options: science, tech, communication and management. Let's see what's in one hot encoding. It is other and science tech. Okay, other science tech. Cool. Now what do we call this? Degree T. Degree T is equal to request dot form degree T. Now we are using if condition. If degree T is equal to I guess science and tech, then other is equal to 0, SC TH. Let give this value as SCTH, or we can give SCI TECH is equal to 1. Elif, I'm sorry, Elif degree T is equal to others, or we can say communication and management. Then for communication and management, my other value become 0 and science tech also become 0. Now for else condition, I will give other value is equal to 1 and science tech value is equal to 0. Now we move forward for next. It is our field work experience. Okay, work experience is equal to, it will be, I guess, integer type. Let me see. Yes, it is of integer type. It is of 1 or 0. So we can use int request dot form for work experience. Yes, let's see what's our next field. Our next field is e-test p. Okay, same e-test e-test uh, p field will be similar like degree p. E-test p is equal to float of request dot form square bracket e-test p. Nice. Now it is a time for specialization. Let me see what we did in specialization. For specialization, we did specialize for fin, or you can say finance, we use 1, and for other we use 0. For finance we use 1 and for HR we use 0. Oh, okay, so this is already one hot and coded, so we have to just import it. So our ID name is specialization. Let me copy this. Here we put ID name. Let's go forward with MBA. It is also of float type, so MBA is equal to float of request dot form square bracket. What's the MBA? MBA is the ID. Now we have to go with status. So it is also one hot and coded. We do not need to worry. Status is equal to int of request dot form square bracket status. Okay, we can remove this. This is nothing but waste for us. So now what we can do, we have to convert this into a numpy array and then perform pick, you can say pre-processing, that is scalar on it, and use transform here. Okay, then predict for this if my prediction will be wait. What is my prediction value? So my prediction value will be salary. Okay, so, and we have to give this variable name say in same as in same order as we did in while training. So we use xtrain. This is our xtrain. In our first we have HCS commerce. Okay, so let me erase all this. These are the you can say features name of previous project, but now I am using features name of current project. So we have to initialize it with commerce science. Okay, first commerce and then science. Commerce, science. After it is for degree, it is other and sci-tech. It is other, then sci-tech. After that it is gender, SSCP, gender, then SSCP. After SSCP we have HSCP and then degree P. HSCP and degree P. Okay, then work experience, E-test P and MBAP. Work experience, E-test P and MBAP. Okay, after MBAP we have to go with status, SSC, HSB and specialization. Status and for SSCB, what we call here SSCB, SSCB Central, then HSCB and at last specialization. Let me cross check it. Yes, SSCB Central, HSCB Central, then specialization. Okay, now it will reshape and then round my value to 2 decimal points, and then it will render the template. It will render the template prediction.html with value this. Let me here use debug is equal to true. Also this. Now let me save this and work on prediction.html. So our project name is campus recruitment prediction. Copy this title and paste it here. Again paste it here. We can use your predicted salary is result. If you can see in app we use result is equal to prediction, so we save prediction value in result, and this variable is nothing but, if you can see here is our result variable. This value we use here to you can say to visualize. Or now let me run this app. Let's see. Yes, it is new, use control plus click to open this. Here you can, oh, so we have to use styling also, but let's see. Male secondary score will be 85, secondary board is central, high school score is 85, or we can give 89. High school board is again central, high school stream it is science. Degree score, let's see, it is 75. Science tech, yes. Work experience, yes. E-test score is my 85. Finance and you can say marketing and finance. MBA score is by you can 79. Status is placed, yes. Let me submit this. Here we get our salary. Let me click a home button again. Give me a prediction for science. And here status is not placed. Here you can, oh, so we are we know that our value cannot be negative, so we have to use one thing. We have to create a condition. Here we can, if prediction is less than we can say less than 0, then prediction is equal to 0. Yes, we can do this. Let me save this and then again restart my web. So it is restart. Okay, let me again do. Now we are predicting, but it is posted. Okay. Let me compute it for low score. Let's see if it gives me 0 or not. So work experience not. MB score is by you can say 58 again, and status is not less. Let's see what happens. Again I'm getting prediction 85, 89, 70. Now why I'm not getting value as 0? Again, let me see from my stream what value I used for. Zero. Prediction to create a, and here status. So 85. Let me do one thing. Open my Google. You can split screen. For male, it is for secondary school it is 85. Board is other. Marks is 89 and board is other. Stream is science. Degree percentage is 75. Degree stream is communication and management. Work experience is no. E-test score is 85. Specialization is HR. MBA score is 79 and status is not less. Let's try again. Here we can see we are getting value as our predicted value, predicted salary is 0. Or we can do one more thing. We can write here in prediction, at last we can use INR. Let's see. See, now it's look nice. It's looking nice. Okay. So here, let me close my web app. Control C. Now, now we have to add styling in our index.html. We can do one simple thing. We can use ChatGPT for that. Use ChatGPT. Here, let we have to write make, or you can say add style in this HTML page. Let me copy the complete code. Here it is. Control A, Control C, and here paste it. Let's run this. So it will add a style header in this. Here you can see it is adding style. I think we should not stroke our web because we use debug is equal to true. So when we you can say change our HTML or app.py, it will affect it on our web app. So let's run this. So we can see changes in real time. The rest of the code here, just copy style, index, not really. We have to put inside head, just paste it and hit save. Now let me launch my app. As you can see, yes, it's looking nice. Yes. Can you do other thing also? I think it is enough. Yes. We can close this and we can close our web app also. Now what we can do, we can deploy this app on EC2 instance. Before that, let me commit my you can say commit my code. So git, oh, this is Python. Git add. So we added all this in staging area. Now we have to commit our commit -n day 3. Now what we can do, it is day 3. Now we push this for push -u origin main. So it is pushed. Nice. So now what we have to do, we can do one more thing also. we can include requirement.txt file for you can say uh, libraries required for running this web app. So let me create a new environment, Anaconda environment here, and there we try to run this, or we can do another thing. Let's try conda create -n. What's my new environment name? It will be campus reg. Okay, campus reg. My Python version should be equal to. Let me again cross check the command. It is conda create -n Python is equal to conda create minus, yes, 3, oh sorry, conda create -n campus campus rec campus, oh sorry, campus rec Python is equal to 3.11.5. Let's run. Okay, hit Y. So let me activate my conda environment, new conda environment. Conda activate campus rec now. So now you can see we are in our new environment. What we can do, we can let me change my directory, and changes come to this directory, campus recruitment prediction, cd projects, cd campus recruitment prediction. Here oh sorry, we cannot run uh, at this moment. We have to install you can say required libraries. Let's see what it needs. It needs Flask, NumPy, request, and pickle. We pip install Flask. Let it install. Okay, but pips dependency is this do not currently take. So we have to first install requests and file lock network, which is not installed, and pillow. Let's try to install request. Now let me try pip install. What we want to install NumPy with version 1.25.2. So pip dependency. Can you copy this? At visit you have missing install numpy version, but yes, we can install this dependency, or so one more thing we have to install, pip install, that is pickle. I guess pickle need scikit-learn. Yes, pickle need scikit-learn library. Scikit-learn is equal to 1.3.0. Let's see. It will install what out. Yes, it is successfully installed. Let's see now our web app will run or not. Python app.py. Let's see. Our web app is running. Okay. Here you can see. Now what we can do, we can close our web app and pip freeze less than requirements .txt. Here you can see we get our file, txt file. We can use conda deactivate. Conda deactivate. So we are in base environment. Let me close this. Let's see. Here we got our you can see dependent libraries. Let me also commit this. First we have to add into staging area, then requirements .txt and also push it also. Now we will deploy it on Amazon AWS EC2 instance. For that I have to log into my account. For a second I will turn off my display. AWS. Here we are. Here. Now our first thing to create the instance, we go to EC2, then instances, and then launch instances. Here we will use a free tier. My web app name will be campus spread. Campus spread. We will take Ubuntu machine. Let me browse all API. Ubuntu 22.04. It is free tier eligible. Let me select this. Also we will take T2 micro. Yes, it is free eligible. It gives us 1 CPU and 1 GB of memory. Okay. We can use no. Always try to create no key pair. So we will give it as name campus spread RSA PAM. Okay. Create key. So this is our private key. We can just launch our instance. It will take around 1 to 2 minutes. So let's go back to our instances. Here we can see it is pending. Let me see, I'm on the mode. Yes. Yes, our instance is running. So we can connect with this. For connecting with our instance, we need putty. Search for before putty. Search for putty gen. We have to convert our public key into private key. First, we have to load. Instead of private key files, we have to select all files. Here we can see there is campus.pem. Now we will save private key. Yes, we give it name as campus spread. Save. Let's go to downloads and see. Here you can see we get our ppk file. So this is a private key for login to our instance. So let me search for putty. PUTTY. Now first we have to give host name or IP address. For IP address, we have to open the instance and so we can connect. Here you can see public IP address. Just copy this and paste it here. For shared session, we can use anything like the campus spread and in connection or something. Username will be, you can see here our username is Ubuntu, so we have to give a username Ubuntu. In SSH we have a go to auth section. We can credentials. Here we have to browse our private key. Here you can see campus spread.ppk. Open and then open, accept. Here you can see now we are connected with our instance. Let me see. Here you can see L. We can type command also. Now what we can do, we have to connect it with the Win SCP also. So we'll upgrade it later. Or we have, here we can see. So let me create it for new host. Username is Ubuntu, and we do not have password, but we have a private key. For that we have to go to advanced. In advanced, go to key exchange, or in authentication. Here select the private key. Select our private key, campus_spread.ppk, and hit OK and login. Yes. So now we are connected to our virtual instance. Here in one side we have our virtual instance, in another side I have my local PC directory. So go back to my campus. Also let me create a new directory here. The keys name is campus prediction. We will you can say copy all web file in this directory. Just a second, we have to change one small thing. Instead of debug is equal to true, we have to use host is equal to 0.0.0.0 and port will be 8080. So we'll save this, and now we can just drag and drop, which you have to you can say copy to this virtual instance. We have to copy templates, we have to copy web app, we have to copy model also, we have to copy scalar also. This time we are not using requirements, we can use, but this time I'm not using requirements.txt, so I'm not copying this file. So now what we can do, we copied. If you want to see yeah, is they are uploaded or not, we can do ls here. Let's see, here you can see here is a directory called campus prediction. Let me change my working directory. So here now it is in, we are in campus prediction. Let me do ls here. Here you can see we have all our files. Now what we can do, now one more thing, we have to connect this to public, so that it will take all requests from public. For that we have to do one thing, we have to change our security group, or you can say we have to add new inbound rules. We can add inbound rules in existing security group, but I am creating a new one. Campus spread, our inbound rule will be all traffic we want access, we want give to access to all traffic with anywhere IP4, and all traffic to IPv6. So we can save this security group. Oh, we also need to add description. We can say same like campus spread create security group. So our security group is created. Now what we have to do, we have to go to instance and click on this instance. Here instance actions, go to security, change security group. Here we have add security group. Search for our security group. Our new security group is campus spread. Let me select this and hit add security group and then save. Here you can see we have in security we have two security groups. One is predefined and another one is campus spread with, here you can see inbound rules, all for anywhere IP4 and IP version v6. Now what we have to do, we have to just install. First we have to update our sudo what's sudo get apt updater. Let me search sudo apt update. Okay, this is the command sudo apt update. So it will update my apt. Now we have sudo how to install Python 3. Install Python. Sudo apt install Python 3. Sudo apt install. I guess we can use Python 3 minus pip. Let's see. Yes, we can also use that command. It will take some time to install. We can hit enter. Now VM guests are running outdated. So it is successfully installed. We can use pip install. Now we will try to install NumPy with version 1.25.2. Let's see. Yes, it is successfully running. It is installed. Yes. Now we will try to install pip install request. So it is already satisfied. Now we will install scikit-learn with version 1.3.0. It is running successfully. Let me see if there is any comment or not. There is. Now we will try to install Flask. For Flask we will use pip install Flask. It started. It successfully installed Flask. Now let me try to run Python 3 app.py. So our web app is successfully running. So for finding and the address, we have to go to instance and click this and click on connect. Here we get an SSH and here we get public URL. Now click here and with port 8080 try to run this. Here you can see our web app is running. And click on submit. Here you can see our web is smoothly running. There is no issue in it. Here you can see. Cool. Now for closing our web, we have to just control C and for let's delete this. Now let me delete this complete instance. For that I have to go to instances. First I have to terminate this. Let me terminate this. It is shutting down. It will take some time. Till then we can do one thing. We can delete our key pairs. Here you can see we have 3 key pairs. We can delete this because we do not need this. We can also delete this one also. Let me delete this instance also. It is terminated. After some time it will not visible to us. So also we have to delete security groups. So we can select all security groups and actions, delete security groups. This security group cannot be deleted, so let me select this default one and then type delete. Here you can see our security groups are vanished. And let's see instance. Both are terminated. Let me go out. So this project is also done, also completed. Now we will work on next project. So when I am surfing Kaggle, I get a new project which is smoking and drinking dataset with body signals. So let's read about dataset. This dataset is collected from NHI's service in Korea. So it is a Korean dataset. All personal information and ancestry data was excluded. Okay. So we have to this EDA will do it later, or we can say, so it has columns like sex, age, height, weight, sight left. You can say eyesight. It is eyesight right here, hearing left, hearing right. 1 is for normal and 2 is for abnormal. Okay. Then systolic blood pressure. Okay, this must be a numeric value, SPP. Okay, diastolic blood pressure, BLDS or FSG, fasting blood glucose. Okay, this is total calories, HDL cholesterol. Oh, sorry, total cholesterol. It is total cholesterol, HDL cholesterol, LDL cholesterol, triglyceride. Then it is hemoglobin. So it is protein in urine. Its possible value is 1, 2, 3, 4, 5, 6. About this minus plus minus plus 1 indicate. We will see this later while we will doing you can say EDA part. It is serum creatinine, serum blood okay, SGOT, AST, okay, ALT, okay, gamma GTP, smoking status. So it is 1 for never, 2 for used to smoke but quit, and 3 for still smoking. Okay, so here is our you can say target variable, that is drinker or not. Okay, so for downloading this dataset we have to do nothing, just click on download. Let me also give this dataset to description also. Let's see this. You can see my dataset is downloaded in archive.zip file. We can get this file. Let's extract file from this. So here is our dataset. We can rename this if we want. Let me rename this as dataset and create a new directory in my projects folder. What is this new project name? So it is smoking and drinking dataset. Okay. Smoking, drinking, classification. So I want to paste my data here. Let me cut this and paste it here. Can delete this. Now what we have to do, let me open this in my VS Code, open folder. It is smoking and drinking, smoking drinking classification. Let me initialize my kit. For that I have to use git init command. Okay, I initialize my empty git repository, git add, or we can say yes, git add dot git commit minus initial commit. So now we will start working on our notebook. Let me create a new notebook called notebook. Let me select the kernel. It will global. Yes, it is global. Now importing accessory libraries. Now we are importing numpy as np, importing pandas as pd, importing matplotlib dot pyplot pyplot as plt, importing cbone as sns. Now importing csv file. So we are saving our csv file in df. So df is equal to, we are using pandas pd dot read csv function. We are giving our file address, or you can say file name. So our file name is dataset.csv, and let's see what's inside this. We are printing 5 sample, you can say 5 sample rows for this. Here you can see, so it has 24 columns and 5 rows. So our target variables, our target value has value in unique value y and n. Let me check the shape of this data frame. Shape of data frame. df dot shape. Oh my god, it has around 9,91,000 entries. Okay, so first we check for duplicate value. Checking for duplicate values. df dot duplicated, we are using duplicated function dot sum. Sum is for it will give us total how many duplicate value it has. Let's see. So it has 26 duplicate values. We can drop this duplicate, dropping duplicate values. For dropping duplicate value, we have df dot drop duplicates, and we want to save the unique values inside this df data frame. So we will use, for that we will use in place is equal to true. So now if we will see shape of df, let's see, it is decreased by 26. Here it is 46 and it is 20, so it is decreased by 26. Okay, now we will check for null values. Checking for null values, and if there is null values, how we have to handle this, we will see soon. Df dot is null is to find the null values, and dot sum is to summarize this. You can see we do not have any null values, which is great news for us. Now what we can do, we can use df.info for getting some insight. You can see our data type is integer, float. Let all values are in float format. Okay, and it is of object. This is object. We can do, let me see, use df.head, how it does. Our I length, okay, so this is also in float, and this is in male and female. Nice. We can do one thing, and now we will let's find correlation between okay, for doing the correlation we must have numeric columns. So let's converting all my two objects d type columns into numeric type columns, or you can say doing kind of one hot encoding. So df of sex is here we can write replacing female with 1 and male with 0. Also let me cross check what's the unique value inside this. It is sex dot unique. Dot needs to find unique values. Hey, we have just two values, male and female. Okay, that's nice. Df of sex. So we are you can say we are replacing value in same column. We not creating a different column for this. So we have to use df of sex, but we have to map our values. Here we have to give our arguments. This we have to give in a dictionary format. We defined our dictionary here, and then for female, for key female, we have to give a value as 1, and for key male, we have to give our value as 0. Let me hit enter. Let's see what it can. So for sex, it is 0 here. Nice. Now we will convert drink y to 1 and n to 0. Okay. df of, let me write markdown also. Replacing here we forgot to write one thing in sex column. Replacing y with 1 and n with 0 in drk yn column. drk is equal to df dot, again df of drk dot map create a dictionary, again for y value is 1 and for n value is 0. Now we can find correlation. For finding correlation we have to use method dot core, and then I'm saving that correlation in core variable. Core is equal to df dot core. Now we are finding, let me see what's inside core. You can see we have correlation value. So we can do one thing. It will be horrible if we try to plot this in a heat map, but let's try this. With annotation is equal to true, annotation is equal to false, else it will be very difficult for us to visualize. By default our annotation is off. plt dot show, or we can do one more thing. Annotation is equal to true, but we will increase our figure size. For increasing figure size we can plt dot fig size, figure here fig size I guess, and let me give 10, 10. plt dot title, correlation between variables. Let me also increase the size. Give me 15,58. Then let's see what happens. Here you can see. So we for if it is around white, it will give me one correlation, that is positive correlation, highly correlated but in positive sense. And for black, or you can say dark maroon, not sorry, dark purple, we have a negative correlation but highly negative correlated. So our target variable is drink y. Let's see for this. You can see this is correlated. So these 3, 4, 5, you can say these 5 are more correlated. We can do one more thing. we can do one thing. We can try to sort this in manner how they are correlated with our target variable. So this is in core data frame, core dot, let's say core for drink. I want to get absolute value dot sort. We have to sort our values with in a descending order. So for that we have to use ascending is equal to false. Here you can see we get our value. So we can so this is used for feature selection. If you can see here, urine protein is you can say close to zero correlated. So we can, if want to ignore, we can ignore this type of feature. But first we have to discuss it with our domain expert. Then we can do this. I think these are 28 variables. So what we can do, we can take just around 15 variables. Let's see. So we can take till dbb 3. So there are 10 variables, I guess. Yes, there are 10. So it is what we can do now. We can do one more thing. We can train our model for our first iteration. We will train our model for all these independent variables, and then in our second iteration we train this model for around you can say 20 variables, or you can say features, and for third iteration we can train our model for just 10 you can say iteration, no, not sorry, for 10 features. And this time I'm not visualizing any data. We can do it later. We can do one more thing. Let's try with first you can say recognize it, or you can say standardize it. For that we will use from first we have to convert this into independent variables. Dependent variables, and save also this into variable to code core y from. And for independent variables we will use x is equal to df of. So if you can see in df we have all independent variable except this drink yn. So we will drop this column, drop this column में drk I guess underscore n, yes, drk underscore yn. y n, and this is our column name, so we have to use x is equal to 1. We can use x dot head also for visualization. Here you can see we get 23 columns. Okay, so we have just 24 columns, right? Now dependent variables, dependent variables, y is equal to df of drk yn by equals 5. Here we get our value. Okay. And one more thing, before we have to, this is a as this is a classification problem, we have to see the value count of you can say yes and no. For that, y dot value count, we will use value count. We want to see is our data set is imbalanced or not. Checking for checking is our data set is imbalanced or not. Imbalance means if my one category have more number of you can say data points and other have less as compared to, but you can see yes, our data set is our data set is not, you can say, imbalanced, or we can say our data set is balanced. So we can now normalize it. For normalization, we will use standard scalarization. We will use standard scalar. Let me import standard scalar. Standard scalar is in scikit-learn. From scikit-learn, import pre-processing, and here it is standard scalar. Let me initialize it. Scalar dot scalar is equal to standard scalar, and then let me know fit for extend and extest. I guess we do not. Yes, we have, before that we have to split our data for testing and training set. Splitting data into training and testing set. Because we will fit our scalar on training data and transform our training and test data. So first, for importing train test split, we have to use from scikit-learn dot model selection import train test split, define x train, x test, y train, and y test is equal to train test split. Here it is x, y. My test size will be 0.2, or you can say my training size will be 80%, and my random state will be 10. We can give any value here. and now we are using stratify. Stratify is equal to y. Now I will explain you what's the meaning of what is the use of stratify. Stratify will split in same ratio, here you can see it is in 1 and 1 ratio, say in x test, and you can say in y train and in y test. Let me run this. Now let me give you the value count. Dot value count for y train and y test. Oh, sorry, it is marked down. I have to write code y test dot value counts. Here you can see these both are in same ratio, but if I will, you can say, remove this part and then split, then there is a possibility that it will the ratio of this will be changed. Here you know, but there is, you can also remove. There is possibility this time this is not working, but we have to certify it with y. Also here you can read about stratify. If not none, data is split in a stratified fashion using this as the class label. Now we can train our we initialized our scalar. Now we will fit and transform. So what it will do, it will in first step it will fit this using x train and then transform the x train. And then we will use for x test also scalar dot transform. What we have to transform? We have to transform x test. Now we can we are ready to go for you can say training part. For training, let's use SVM using training the model. So let me give this in heading format. Now we have from scalar dot svm we have to import svc model is equal to svc model dot fit x train y test. Oh sorry, not y test, we have to train y train, we have to use y, and instead of x train we have to use x train scaled. My bad. Model dot score y test, again for x test scaled. Let me cut this part. Or instead of model, let me try SVC. Control X. Till then it is training. Let me import uh, my confusion matrix and my classification report, because this will give me just accuracy score, and in classification we cannot rely on just accuracy score. We have to see our precision and recall value also. And let's say for from scikit-learn dot matrices we have to import we, we have to import first we have to import our confusion matrix, and then classification report. Okay, let's create a confusion matrix for this model. We can save this in ypred is equal to we are predicting for x test, and then we will save this in ypred using svc dot pred function. We are predicting for x test scaled, and then what we are doing, we are creating a confusing matrix that which we save in cm variable confusion matrix. What's our here variable? It is y true. First we have to give true value, that is y test, then our predicted value is y pred. Then we can just do cm. Also we can print our classification report. Similarly, first we have to give y true. In y true we have to use y test, and for y pred we have y pred. Just then we can wait. Why this is taking so much time? Till then we can do one more thing. We can find visualization for our data also. We can do that. May copy all column names. Let me paste it here. printed name 0. Let me cut this and paste in ChatGPT. I have data frame, or we can say data set, with this 24 columns. Give me ideas for visualization. What insights what can what information can I get use this data? So it's giving me a distribution, sex distribution. Let's see, our model is trained or not. No, it is still training. We can use logistic regression also, using SVC algorithm. We can also use logistic regression, but logistic regression is a linear model import logistic regression. CV is for cross validation. If we use CV, it will hypertune which hyperparameter is best for our this model. Okay, log reg log reg log reg dot pred for x test scared y test. Instead of SVC we can use log reg, sorry. Why it is taking so much time? We can do one thing. You can interrupt this folder and restart this. And instead of CV, we will just use CV. Just CV. Just simple logistic regression. choosing gestic regression model. Let me comment this out. Also this. And then run with the entire node. Let's see how much time this time it will take. The two positions, but 3 were given. Why this is not predicting? Oh, sorry, not predict. We have to use score. I'm sorry. Here you can see we are getting around 72% precision for 0 and 72% recall for 1. And our accuracy score is around 73%. Here you can see. And this is our confusion matrix. We can also convert this confusion matrix into heat map if we want. We can do SNS dot heat map and give this CM variable inside here, and note is equal to true dot show. Here you can see. Also we can change this format also using the variable name. Just a second. Let me also add title also. Title. My title will be correlation. Oh, sorry. Confusion matrix. Auto. Let me search for auto. Cador. What we can do, we have to do ChatGPT. How to change format of annotation in heat in seaborne dot heat map. Oh, okay, it is for FMT. So here you can see, if we put 0 here, This is looking nice. Now we can also train our model for, you can see, random forest. Let's see how much accuracy we will get from scikit-learn dot ensemble import random forest classifier. And, let me initialize random for. Oh, wait a minute. We can also do it for logistic regression CV crossfade. Let's see how much difference we get in this score. Here our value is 73, 72, and 73. Till then, we will do this. Forest is equal to random forest. An estimator will be 50. And criteria will be, you can see our data set is big, so we can use Guinea here because Guinea will perform, you can say, take less time as compared to entropy. And what else we can do? We are getting the same result. And forest dot fit on, we will fit extrain, not extrain scaled. There is no difference in extrain and extrain scaled and simple extrain, because in random forest we create decision trees, or you can say we split our data using if-else condition. Forest dot score x test comma y test. Let's see. Using random forest classifier. Also, we can print classification report for this. Before that, we have to write widespread variable forest dot predict. We have to predict for x test, then print classification report, and in classification report we have to use x test first, the y test first, and then y pred. Let's see how much time it will take. It is training. Let me see if there are any comment or not. If you have any query, you can comment down in this video. I read all comments. I think from next time I have to use Google Colab because it seems my PC is getting slow. Till then uh, we can draw visualization. What we can visualize, we can do histogram or bar chart. Visualize the distribution of ages to understand age demographics in dataset. Okay, we can do PSMS dot histplot with data as DF and X as age with bin size as 10. PRT dot title age distribution. PRT dot X label age, and in PRT dot Y label we can use we can use count and use PRT dot show for visualization. And for sex distribution we can do the same thing. Also we can change X tick. PRT dot X tick. Here let me give 0, 1 label. Now we are giving label for 0 it is male and for 1 it is female. Here our model is true. We have to give this in array. Let's see. Let me just see this label. How we have to give the register label. So in a okay. 0 is for male and 1 was for female. Here you can see or we can use plt.histogram for this. df of 6, comma, bins is equal to 10. Here you can see. Here also we can in this you can see we got 73 for reference score, 73 for 1 for reference score, and accuracy is 73. From this two algorithm we can see random forest is performing better. Now which algorithm we can use? Now we can use a gradient descent classifier. So let me select from scikit-learn dot ensemble, import gradient boosting classifier. Grad is equal to gradient boosting classifier. I will give default parameter grad or fit. It is on x train scaled dot score test scaled y test. Here let me cut this cell. Yes, we can paste it here. And then we can do same thing with this. Instead of forest, we can use grid. Oh, we have to predict for x scaled. By mistake, I typed x test. Gradient using gradient boosting algorithm. Now we move towards our distribution. We can scatter plot height versus weight. Yes. For scatter plot, we have SNS dot scatter plot for data. Data is our TF. X is our, we can say, height, and Y is our weight. Also, we can use Hui for you can say DRKYN. Let's see. I guess it is DRKYN. Let me cross check it. Here, DRKYN. Created title with the scatter plot between that between height and weight. PRT dot x label. X label will be what? Height, and PRT dot y label will be weight. Let me use PRT dot show. Similarly, we will create scatter plot for waistline and BMI. We can copy the entire thing and paste it here. Instead of uh, height, we can use BMI. Is BMI capital or not? Let's check. Our BMI column is there is no column name BMI. I think we have to calculate first BMI. Okay, let me check our data frame from here. Height is in centimeter and weight is in our kilogram. BMI calculator. Check with the it is in centimeter, it is in centimeter, and weight is in kilogram. Okay. BMI formula. We can do. So we have to multiply this with 10,000 because here it is meters and meter square, so it will go to 4 decimal point. Okay. We have to first create TF of BMI. BMI will be DF of weight into 10,000 divided by DF of height. And instead of weight, we have to use waistline. Okay. Waistline. Waistline. Okay. Scatter plot between BMI and waistline. And our X label will be BMI and Y label will be waistline. So our model is trained. We can see we are getting again 73% apple score and 74%. Okay. We can ignore this, you can say, warnings also using importing warnings. Let me use that warnings here. Import warnings and then warnings dot filter warnings and ignore all warnings. Let's see what's our scatter plot. Okay. Here you can see there is much chances who has you can say who has higher height have higher chances of drinking. Let's wait for this visualization and then till then we can use box plot for blood pressure distribution. Note SBP and DBP. Okay. Here you can see we are getting the scatter plot between BMI and waistline. Okay. I think this is enough for today. In tomorrow section, I'm sorry, I will not be available for 3 days. I am out of station. So in our next section, we will try to complete this visualization and select a best fitted model for this problem and then hypertune that model.